In this grid, there are 4 multiplications. Write the 3 missing numbers. So for this box here, in front of it, we have 4 times 8 equals, so that's 32. And for this box here, above it, we have 4 times 3 equals, so that's 12. And then for this box here, if we look at the row, we have 3 times something equals 21. And if we look down, we have 8 times something equals 56. So the missing number here is 7. 3 times 7 is 21, because 21 divided by 3 is 7. And 8 times 7 is 56, because 56 divided by 8 is also 7. What number is 1,000 less than 9,072? So to find the number 1,000 less, we need to subtract 1,000 from this number. Now we could use column subtraction, but if we're subtracting 1,000, all we really need to do is find our thousands digit, so that's the 4th digit from the right if we have a whole number. So 1 less than 9 is 8, so our answer is 8,072. So the 072 in our hundreds, tens and ones stays the same in our answer, because we're not subtracting any hundreds, tens or ones. We're subtracting 1,000, so the thousands digit decreases by 1. Order the numbers starting with the largest. Match each number with its order. So when we compare numbers, we start by comparing the most significant or largest place value. So that's the place value furthest to the left, which here is our millions. But all of our numbers have 1 as the millions digit. So we can move across and look at our hundred thousands digits. We have 0, 0, 0, 2, so that means this number here with 2 in the hundred thousands will be our largest number. Then, because all of our other numbers have 1 in the millions and 0 in the hundred thousands, we can look at the 10,000s. We have 0, 2, 0, so this number with 2 in the 10,000s will be our second largest number. Now, both of our other numbers have 9 as the thousands digit, so we need to go all the way over to the hundreds. Here we have 9, and here we have 0. So the number with 9 in the hundreds will be next, and then the number with 0 hundreds will be our smallest number. Here is a shaded shape on a square grid. Reflect the shape in the mirror line. So the way to do this is to dot the corners. So if we take this corner here, that's 2 to the right, so we can go 2 to the left and dot the point. This point here is 4 to the right, so we go 4 to the left. Here we go 3 to the right, so we go 3 squares to the left. This point here is 1 to the right, so we go 1 left. And here we have 4 squares to the right from the mirror line, so from the mirror line we go 4 squares to the left. And now that we've dotted our corners, all we need to do is join them up, and we've reflected our shape so that we have the same on both sides in the mirror line. The numbers in this sequence increase by 45 each time. Write the missing numbers. So we know that the numbers increase by 45 each time. So for this box here, we have something plus 45 is 155. So we really have a missing number addition, which means we can find the missing number by subtracting. So working out 155 minus 45. That gives us 110. So 110 plus 45 will be 155. Now for this box, we have 245 plus 45, which is 290, and here we need to work out 290 plus 45, so that's 335. Write the missing number to make this division correct. We have 0.3 divided by something equals 0.03. So we can see that we have the digit 3 in both our dividend and our quotient. And all that's happened is that the 3 has moved to the tenths place, so moved from being the first digit after the decimal point to being the second digit after the decimal point. So that's moved from the tenths to the hundredths place. So because the digit has moved one square to the right, that means we've divided by 10. Because with 10 we have 1 0, so we've moved one square. Remember, if the digits move 2 places or 2 squares, that's dividing by 100, and if they move 3 squares, that's dividing by 1000. But here the digit has only moved one place or one square, and that's dividing by 10. Jack pours some dark paint into a container. In litres, how much paint is in the container? So we have 5, 4 and 3 litres marked. So this line that's right in the middle of 4 and 5 will be 4.5 litres. This line here, right in the middle of 3 and 4, will be 3.5. So that means this line here, where the paint is, will be 2.5 litres. And 2.5 litres is the same as 2.5 litres. So here we could either write our answer as 2.5 or as 2.5. And then we can check to get from 5 to 4.5. You can see that we go past this little line, so that would be 4 3/4. And to get from 4 to 3.5, again we go past a little line. So that means to get from 3 to 2.5, we go past this little line, which would be 2 3/4, but the paint is at 2.5. In this sequence, the rule to get to the next number is multiply by 2 and then add 3. Write the missing numbers. So the rule is times 2 or multiply by 2 and then add 3. And we can see how this works because 25 times 2 is 50 plus 3 is 53. So now to find this number here, we need to multiply 53 by 2, so that's 106, and then we can add 3 to get 109 as our answer here. But now for this box we have something times 2 plus 3 equals 25. So we need to work backwards. Instead of adding 3, because we're working backwards, we need to use the inverse and subtract 3. So 25 minus 3 is 22. And then instead of multiplying by 2, if we're using the inverse or opposite, we need to divide 22 by 2. And that gives us 11 for this box here. And then we can check that it works because 11 times 2 is 22, and then 22 plus 3 is 25. So that's the next number in our sequence. Jack chose a number. He multiplied the number by 7, then he added 85. His answer was 953. What number did Jack choose? So we know that this is a working backwards problem because we know the answer and we want to know the number that he started with. So what we can do for working backwards problems is draw a diagram to show what's happened. So Jack chose a number. He multiplied the number by 7, so we can write times 7 with the first arrow. Then he added 85, so we can write plus 85 with the next arrow. His answer was 953, so after he'd added 85, he got 953. So first, let's work out this number here. Something plus 85 is 953, so we can get our answer by subtracting 85, because we're working backwards, so we can use the inverse. And that gives us 868. Then we have times 7, but because we're working backwards, we can divide 868 by 7, and that gives us 124. So that's the number that Jack chose. A theme park sells tickets online. Each ticket costs £24. There is a £3 charge for buying tickets. Which of these shows how to calculate the total cost in pounds? So if each ticket costs £24, the word each tells us that we need to multiply the number of tickets by 24. So if one ticket costs £24, then 2 tickets will cost 2 times 24, or £48. And then there is a £3 charge for buying tickets, so no matter how many tickets you buy, you will be charged £3 extra, so that's plus £3. So we need to tick this statement here. The number of tickets times 24 plus 3 shows how to calculate the total cost, because we multiply the number of tickets by 24, but then we need to add £3 because there's a £3 charge for buying tickets. Amina is shopping. She says, I would like to buy 1/4 of a kilogram of cheese. Write 1/4 on the scales as a decimal. So we need to remember that with decimal place value, we have tenths, hundredths, and thousandths. Now we can't change 1/4 into tenths because 10 is not a multiple of 4. But we can find an equivalent fraction with a denominator of 100 because 4 times 25 is 100, and with equivalent fractions, what we do to the denominator, we do to the numerator as well. So 1 times 25 is 25. So because 1/4 is the same as 25 hundredths, we can write that as 0.25, because the second digit after the decimal point is our hundredths digit, but because we can only have one digit in each place value, the 2 gets pushed over to the tenths, so 1/4 as a decimal is 0.25. The cheese costs £1.35. Amina pays with a £2 coin. How much change should Amina get? So she pays with £2, but it costs £1.35, so we need to find the difference. £2 can be written as 2.00, so if we subtract £1.35, that gives us £0.65, or 65 pence change. Here are 3 symbols: less than, greater than, and equals. Write one symbol in each box to make the statements correct. So here we're comparing fractions and decimals. So either we need to change our fractions to decimals or our decimals to fractions. If we change fractions to decimals, 7/10 is the same as 0.7, because the first digit after the decimal point is the 10th digit. But 0.7 can be written as 0.70. We can write zeros on the end of decimals without changing the value of the number. So that's why 0.7 or 7/10 is greater than 0.07, because 7/10 is more than 7 hundredths. Now we have 23 thousandths, so we can write that as 0.023, because remember, after the decimal point, we have our tenths, then our hundredths, and then our thousandths, and the denominator of 1,000 tells us that we need 3 digits after the decimal point, because we need to go all the way over to the thousandths digit, or the thousandths place. But because we have 23 and we can only have 1 digit in each place value, the 2 gets pushed over into our hundredths place. So remember, if we can't fit more than 1 digit in a place value, digits get pushed to the left. So we have 0.023 and 0.23. Now when comparing decimals, I find it easier, like we did here, to write zeros on the end so that we're comparing decimals with the same number of decimal places, and then it's easier to see why 0.023 is smaller than 0.23. Here is a sketch of a triangle. It is not drawn to scale. Draw the full-size triangle accurately below. Use an angle measurer, protractor, and a ruler. One line has been drawn for you. So they've drawn the line at the bottom, and we can see that this angle here is 35 degrees, and this angle is a right angle, so 90 degrees. So what we can do is get our protractor, and if we start by finding 35 degrees, we need to make sure that we've lined up our protractor with the edge or the end of the line, so that you can see this cross in the protractor that's right on the edge of the line. And then we can see that here we're going to be using the inside scale of the protractor, because the other thing that we've made sure to do is to line up this line of the protractor with our line, so that the 0 is right on the line. And now we need to find 35. So we have 10, 20, 30, 40. So 35 will be right in the middle. So that's this point here. And now what we want to do is draw or dot. So now that we have our dot to show 35 degrees, we can take our protractor off the page, get our ruler, and then draw a line from the end of this line so that it goes right through the middle of our dot. So now we can draw our 90 degree or right angle. So again, we can get our protractor, and this time we've lined it up with this end of the line, so we can see that the cross on our protractor is right on the end of the line. We've also made sure that we've lined up the line on the protractor with the line that's drawn for us, so that we've got 0 right on the line. And this time we can see that the 0 is the scale on the outside of the protractor. So we have 10, 20, 30, we can go all the way to 90, and then again we want to draw a dot. So that means that we can take our protractor off the page, and this time we're drawing a line from the end of this line again so that it goes right through the middle of the dot. And then you can see we've got this little bit extra that we don't need, so we can rub this out, and we've drawn our full-sized triangle accurately, because we measured 35 degrees here and 90 degrees here. Complete the table. We need to round 39,476 to the nearest 10,000, the nearest 1,000, and the nearest 100. So to round to the nearest 10,000, we first need to find our 10,000s place value. So remember, with whole numbers, starting from the right, we have our ones, tens, hundreds, thousands, and 10,000s. So we can circle our 10,000s digit, and then to decide whether to round up or down, we look at the digit to the right. And if it's 5 or more, like it is here, we round up. So that means the digit we've circled increases by 1, so the 3 becomes a 4, and our other digits or digits to the right turn into zeros, so that's 40,000. Now to the nearest thousand, we find our thousands place, and this time when we look at the digit to the right, we have a 4, and if we have 4 or less, we round down, which means the digit that we've circled stays the same. Now digits to the left of what we've circled always stay the same, and again digits to the right turn into zeros, so that gives us 39,000. And finally, to the nearest hundred, we can find our hundreds digit, and when we look to the right we have a 7, so we have 5 or more, which means we round up. So this 4 will become a 5, the digits to the left will stay the same, and the digits to the right of what we've circled turn into zeros, so that gives us 39,500. Amina asked 60 children to choose their favourite flavour of jelly. These were her results. What percentage of the 60 children chose orange? So we can see that 15 children of the 60 children chose orange, so we can write that as a fraction. 15 out of 60, we can write 15 over 60. But we need to remember that a percentage is a fraction with a denominator of 100. But 100 isn't a multiple of 60. We can't multiply 60 by a whole number to get 100. So what we need to do here is simplify the fraction first. Both 15 and 60 are in the 15 times table, so we can divide both the numerator and denominator by 15. So 15 divided by 15 is 1, and 60 divided by 15 is 4, because 4 times 15 is 60. So now that we know that 15 out of 60 chose orange, and that's the same as 1/4, or 1 out of 4, we can find an equivalent fraction with a denominator of 100, because 4 times 25 is 100, so if we do the same to the numerator, 1 times 25 is 25. So we found that 15 over 60 is equivalent to 1/4, and that's equivalent to 25 hundredths. So if we have 25 hundredths, we have 25%. So that's the percentage of the children who chose orange. Write the missing number. We have 6 plus 2 times 2 minus something equals 6. So here we have a calculation with mixed operations. We have addition, multiplication and subtraction. And we need to remember that we do multiplication before we do addition and subtraction. And the way I remember that is that addition and subtraction are easy, and we leave the easy stuff till the end. So we need to do the multiplication, so do 2 times 2 first. So 2 times 2 is 4, so we have 6 plus 4 minus something is 6. So 6 plus 4 is 10, and 10 minus 4 is 6, so that means our missing number is 4. These two shapes have the same perimeter. The length of each side of the hexagon is 8 centimeters. Calculate the area of the square. So we need to remember that the perimeter is the total distance around the outside of the shape, but the area is how much space a shape takes up. Now we can also remember that with a square, all of the sides will be the same length, and with a regular shape, all of the sides are the same length as well. And if we know the side length of a square, we can find the area by multiplying the side length by itself. So what we need to work out in order to find the area is find the side length of a square. Now we're told that the length of each side of the hexagon is 8 centimetres, and we're also told that the two shapes have the same perimeter. So let's start by finding the perimeter of the hexagon. We have 6 sides in a hexagon and each side is 8 centimetres, so that's 6 times 8 or 48 centimetres altogether. So that's the perimeter of the hexagon, and we know that the perimeter of the square will be the same, so will also be 48 centimetres. Now with a square, we have 4 sides of the same length. So to find the length of one side, if we know the length of 4 sides, so the perimeter is 48, we can find the length of one side by dividing 48 by 4. So that's 12, which means the square has sides of 12 centimetres. Now we need to calculate the area of the square, and to calculate the area of a square, we multiply the side length by itself. So 12 times 12 is 144, which means the area of the square is 144 centimetres squared. Circle the prime number. Explain how you know the other numbers are not prime. So a prime number is a number with only 2 factors, a number that's only in the 1 times table and its own times table. So the prime number here is 89. We know that 95 can't be a prime number because 95 is in the 5 times table. We know that any number that ends in a 5 or 0 will be a multiple of 5. And if we divide 95 by 5, we don't get a remainder. So we know that 19 times 5 is 95. And 87 is in the 3 times table. And we know that because if we divide 87 by 3, we get 29. So we get a number with no remainder. And that means that 29 times 3 is 87. So to find if a number's prime, one thing to do is look at the last digit of a number. If it's a 5 or 0, you know that it will be in the 5 times table as well. And if it ends in 2, 4, 6 or 8, you know that it's an even number, so it will be in the 2 times table as well. But here we have a number that ends in a 9 and a number that ends in a 7. So what we can do for these numbers is try dividing them by 3 or by 7, and if we don't get a remainder, then we know that it's not a prime number. So here, because we didn't get a remainder for dividing 87 by 3, we know that 87 is in the 3 times table as well, so not just in the 1 and 87 times table, but also in the 3 times table and in the 29 times table. So 89 is only in the 1 times table and the 89 times table, and a number with only 2 factors is a prime number. So 89 only has the factors 1 and 89, so only 2 factors. Whereas the other numbers, so 95 and 87, have more than 2 factors. 95 is not just in the 1 and 95 times table, but also in the 5 and 19 times table. A machine pours 250 millilitres of juice every 4 seconds. How many litres of juice does the machine pour every minute? So we know that there are 60 seconds in 1 minute, and it pours 250 millilitres every 4 seconds. So let's work out how many times 250 millilitres will be poured. So it's poured every 4 seconds for 60 seconds, and if we divide 60 by 4, we get 15. So that means 250 millilitres is poured 15 times. So to work out how much juice is poured, we can multiply 250 millilitres by 15. So we could use long multiplication to work this out, and that would give us 3,750. But that's the number of millilitres, and we want to know how many litres. So remember, there are 1,000 millilitres in 1 litre, so we can divide by 1,000, and the easiest way to do that is to imagine the decimal point on the end, and because there are 3 zeros in 1,000, we can move 1, 2, 3 places to the left, and that gives us 3.750, which we can just write as 3.75 litres, because we don't need to write zeros on the end of decimals. The other way to solve this problem is by scaling up. So we know that 250 millilitres are poured in 4 seconds. So if we double or multiply by 2, 250 times 2 is 500, and 4 times 2 is 8. So that's 500 in 8 seconds, but we want 60 seconds, so let's double again. Double 500 is 1000, and 8 times 2 is 16. Then, if we double again, 1000 times 2 is 2000, and 16 times 2 is 32. Now, if we doubled again, that would give us 64 seconds. But that would be too many. Now, we could do that. We could get 64 seconds and then subtract 4 seconds, so subtract 250. Or we could work out that if we add 32 seconds and 16 seconds, that will give a total of 48 seconds, and 2000 plus 1000 is 3000. So in 48 seconds, we can pour 3000 millilitres, and if we add 8 seconds to 48 seconds, that tells us that we can pour 3,500 in 56 seconds, because 32 plus 16 plus 8 is 56, and 2000 plus 1000 plus 500 is 3,500. So then we just need to add another 4 seconds, so add another 250 millilitres, and that gives us 3,750 millilitres, which we can then change to 3.750 or 3.75 litres. Tick the fractions that are equal to 20%. So we need to remember that a percentage is a fraction with a denominator of 100. So we need to find which of these fractions are equivalent to 20 hundredths. First, we have 1 over 20. Now 20 times 5 is 100, but 1 times 5 is 5. So 1/20th is the same as 5 hundredths or 5%, not the same as 20%. Now we have 20 over 40. So 20 over 40 will not be the same or equivalent to 20 over 100. So we know that this will not be equal to 20%. We could simplify 20 over 40 to 1/2, because 20 is half of 40, but 1/2 is the same as 50%, not 20%. Now we have 1/5. 5 times 20 is 100, because 100 divided by 20 is 5, and then 1 times 20 is 20. So because 1/5 is equal to 20 hundredths, that means that it's equal to 20%, so we can tick 1/5. Now we have 3 over 15, but 15 is not a factor of 100. So how can we change a fraction with a denominator of 15 to a fraction with a denominator of 100? Well, what we can do is simplify the fraction first. Both 3 and 15 are in the 3 times table, so we can divide both the numerator and denominator by 3. So 3 divided by 3 is 1, 15 divided by 3 is 5. So because 3 over 15 is the same as 1/5, and we've seen that 1/5 is equivalent to 20 hundredths. 3/15 will be equivalent to 20% as well. And now 2 hundredths is not the same as 20%, because if we only have 2 hundredths, then we have 2%, not 20%. Adam has this rectangular piece of card. It is marked with grid lines. Adam makes 2 straight cuts along the grid lines. The 2 cuts divide the rectangle into 3 shapes: 2 squares of different size and 1 rectangle. Using the grid lines, draw 2 lines that show where Adam could have made his cuts. Use a ruler. So we need to remember the difference between a square and a rectangle. With a square, all of the sides are the same length, but with a rectangle, the sides can be different lengths as long as opposite sides are the same length. So one of his cuts could be here. That makes a square because we have a length of 5 on all of our sides, so we have a square. But then we need another square and a rectangle. So we could make a cut here, because then we have a square, because in this square all of the sides are 2 lengths, and here we have a rectangle because we have a width of 2 and a length of 3. Or we could have a cut here, because then we have a big square on this side that's with a length of 5 centimeters for the sides, and then we could have a cut here, because then we have a square, so 2 by 2, and we have a rectangle, so 3 by 2. Or we could have our square at the bottom, so that's a length of 2 for all of our sides, and then our rectangle, so our 3 by 2 square rectangle at the top. This graph shows the maximum temperature for 5 days. For what fraction of the 5 days was the maximum temperature below 10 degrees? So what we can do is find 10 degrees, and if we draw a line across, we can see that 2 of the days have a maximum temperature below 10 degrees. And there are 5 days altogether. So remember, the numerator of the fraction is how much we have, and the denominator how many there are altogether. So because we have 2 out of 5 days, we can write the fraction as 2/5. Now, what was the mean maximum temperature to 1 decimal place? So the mean is the average, and to find the mean, we add up the total of what we have and then divide by the number of things. So here, divide by 5 because we have 5 days. So 8.1 plus 9.3 is 17.4. 17.4 plus 11.9 is 29.2. 29.2 plus 11.8 is 41.0. And then if we add 12.4 to that, we get 53.4. And here I've added mentally, but you probably want to use column addition for this to make sure you add up the total correctly. So the total is 53.4, but we have 5 days, so we need to divide 53.4 by 5. So 5 divided by 5 is 1, 3 divided by 5 is 0, remainder 3, so we can copy up our decimal point and write our remainder 3 in front of our 10th digit. Now 34 divided by 5 is 6, remainder 4, so we need to extend with a 0 and write our remainder 4 in front of our 100th digit. And we can do that because 53.40 is has the same value as 53.4. Remember, you can write zeros on the end of decimals without changing the value of the number. So now 40 divided by 5 is 8, so the mean is 10.68. But we want the mean to 1 decimal place. So 1 decimal place is the same as rounding to the nearest tenth, so that we only have one digit after the decimal point. So what is 10.68 to the nearest tenth, or to one decimal place? Well, remember, to decide whether we round up or down, we look at the digit to the right. And if we have 5 or more, like we do here, we round up. So that means the 6 will become a 7, so we have 10.7. And with decimals, we don't need to change digits to the right to zeros. We can ignore the zeros on the end, because 10.7 is the same as 10.70. So our answer is 10.7 degrees. Amina made this cuboid using centimetre cubes. Stefan makes a cuboid that is 5 centimetres longer, 5 centimetres taller, and 5 centimetres wider than Amina's cuboid. What is the difference between the number of cubes in Amina's and Stefan's cuboids? So first, we can find the volume, or the number of cubes, in Amina's cuboid, then find the number of cubes in Stefan's cuboid, and to find the difference, we subtract. So first, let's find the number of cubes, or the volume, of Amina's cuboid. To find the volume, we multiply the length, width, and height. So we can work out 4 times 6 times 3. 4 times 6 is 24, and 24 times 3 is 72. Or an easier way to do that, 4 times 3 is 12, and 12 times 6 is 72. But now let's find the volume of Stefan's cuboid. It's 5 centimetres longer, taller, and wider, so we need to add 5 to 4, 6, and 3. So that means the dimensions of Stefan's cuboid is 9 by 11 by 8. So 9 times 11 is 99, and 99 times 8 is 792. So Stefan's cuboid has a volume of 792 centimetres cubed, and Amina's has a volume of 72 centimetres cubed. So we want to know what is the difference, and we find the difference using subtraction. So if we subtract 72 from 792, we get 720. So the difference is 720 cubes.